can't add any more methyl groups.
So is this an example, what you just showed us right here, an example of methyltransferase? Is that what you're showing
In this
us?
case, yes, because the methyl, I'm not actually showing methyltransferase,
Okay.
but I'm showing the allosteric molecule changing shape,
Okay.
exposing amino acids. Then that allows transferase to
Okay.
bring in the methyl groups.
Okay.
So I'm not actually showing it, but that is what's going to happen. Yeah.
Okay.
Yeah. Yes.
Tumbling is when it goes demethylated and then demethylated, right? But if you just kept methylating, wouldn't the bacteria just go in a circle? It's always going counterclockwise.
Well, it will, yes and no. Her question is, if you're only methylating, if you're only adding attractant, shouldn't it just go in one direction? Well, yes, in a perfect world, when bacteria have GPSs. But bacteria are bacteria. They do get lost. So even in the presence of an attractant, the bacteria can still go off in the wrong direction, and it still then needs to tumble to try to go in the right direction. Now, if you're actually giving it maltose instead of making it find it, then that might be a little bit better, and it won't need to tumble as much. In my campfire example, it had to find the attractant.
When it's trying to find the attractant, what does it do when it gets there?
It eats it, just like we do. When we're smelling food, we eat it, you know. So it does what we do. See, I'm glad we did this, because clearly there's a lot of confusion. So I'm glad we're trying to go over this again.
It's a really good review.
Yeah.
Today alone made more sense of all yesterday. So
Good,
Good
good.
job.
Thank you. I know that was said with sarcasm, but
No,
I'll take it.
no sarcasm.
See, I don't mind sarcasm. Any other questions on this? Remember, your midterm will be next week. And I can still answer more questions. You know, we're not done, but it's at least semi-clear now. You can go home and look at it. Okay. So anyhow, the whole idea then is you're exposing glutamyl residues or glutamic acid. That is what becomes methylated.
I just want to ask one more question.
Yeah.
To be clear. So basically, it can get full with its
You bet, of course.
glutamic acid by searching just as much as actually receiving the.
Stimulus is a stimulus. It doesn't matter what kind of stimulus. It doesn't matter what the form is. The stimulus is a stimulus. It's going to cause this. You got to have receptors. And sooner or later, your receptors get full. It does not matter what kind of stimulus. I mean, because they all do the same thing.
But it could get full before the bacteria even reaches what it
You
wants.
bet it can. Absolutely. Yes, it can. So then it's done. So it never gets there. Because it won't respond anymore. So that's the whole point. Hopefully, it's got enough receptors, it can
Yeah.
actually get to the goal. But it might not.
Can you tell like other bacteria? You can't
Talk
like.
to bacteria, no. No. Or not?
So, okay, let's say the other way, so in the presence of a repellent and demethylation is occurring. So there's the whole, like, let's say there's a repellent, there's a repellent binding protein complex or whatever.
Yeah,
Bind this,
same
and
process.
still- So then is that, because now it's their protein. the
Guys,
shape-
come on.
The
Huh?
shape is changing, so is that still, exposing the,
Yes.
the glutamyl residues?
Yes.
So instead of methylating them, it's demethylating?
Yes.
Um,
Everything's the same, except for the repellent. If she's asking about if the repellent, does anything change? The answer is no. The whole process is the same. Whatever your repellent is, it's going to bind to a binding protein. It's going to attach, activate the binding protein, attach to the MCP. You're going to expose all of this, but now you have esterase coming in, not transferase, removing the methyl groups. Everything's the same. Now remember,
Does it recoil then?
what?
Does it recoil?
It will,
Yeah.
because no stimulus stays forever. The stimulus sooner or later is going to stop. Once it stops, there's no stimulus, everything goes back to the way it was.
So it can recoil either without a stimulus or with a repellent.
Yes. Either way. Yep.
And getting
Wait.
recoiled all the way back up would be kind of the same thing as being saturated.
Yeah. It's just a one-celled organism. Think if we were doing two cells, it'd be much worse. No, that's really the amazing thing. This complexity is a one-celled organism. To actually deal with mammals and stuff is a whole different level of achievement. Okay, so methyltransferase does the methylating and with the repellent you have esterase. And that's pretty much where we stop. I do actually want to continue a little bit longer, so we'll delay our lab for a little bit. But any other questions on this? And again, you can still ask next week. You can still email me over the weekend if you come up with something. But any questions? All right, y'all okay? Okay. Well, let's move on from this. Let's get out of here, or at least get out of this. So let's go back to something that's actually in your book.